Greetings, grade 5s, you wonderful children, you mathematicians of the future. Welcome to today's maths lesson, all about how to subtract mixed numbers. I'm Mr. T, your math teacher for today. At Worksheet Cloud, we're all about having fun while you learn, which is why we have our brand new rewards hub where you can earn rewards while you're learning. Rewards like merchandise from Worksheet Cloud, hot chocolate from Nomu to make those study breaks just that much sweeter, or possibly even a PlayStation 5. Who knows? Could be you. Special shout out to those of you who are already part of the Worksheet Cloud clan. Hopefully we'll have more of you soon. Anyway, on to today's maths lesson. We're looking at subtracting mixed numbers. Mixed fractions, it's the same thing. Some teachers call it one, some the other. But it's numbers where we have a whole number and a fraction part in the same term. Right, our goals for today. Pretty simple, be able to subtract mixed numbers with and without borrowing from the whole number. Hopefully that will make a lot more sense once we get going with the lesson and you start to see what it is I mean by borrowing from the whole number. Prior knowledge that will help you with this lesson. If you know how to subtract common fractions, that would be good. And also part of the whole subtracting fractions is finding equivalent fractions to make it possible to subtract. Right, if we just have a quick reminder of what it means when we are subtracting fractions that are common, we can have situations where both our denominators are the same in the question. So 5/6 minus 3/6, we simply subtract the numerator. So 5 minus 3 is 2, and we are looking at 6, so that stays unchanged. Right, I'll have a look at why it stays unchanged on the whiteboard in a moment. We also have situations where the denominators are different in our questions. And by now you should be familiar with the rule that before we add or subtract fractions, we have to make sure that our denominators are the same. So I noticed that we could change that 3 into a 6. So we would double this fraction. So we double the 3 and we double the 1 and we'd get 2 over 6. So we keep the same fraction the same, and in this one we double. Becomes 2 over 6. Now our denominators are the same. We'll be able to subtract just like we did up top. And we get 3 over 6. Sometimes we come across situations where our denominators are different and we can't change one of the denominators into the other. We have to change both of them into something else altogether. In other words, we have to find something that 3 and 4 both go into, our denominators. In other words, we're looking for the lowest common denominator, the smallest number that both 4 and 3 go into. So I notice, I'll run through how we can get there on the whiteboard, but I noticed that 4 and 3 both go into 12. So I'm going to convert both of these into fractions over 12. So I'm going to times this by 3, and what you do to the bottom, you do to the top. So I'm going to times both of those by 3, and this one I'll times by 4 to get to 12, and I'll do the same to the top. So 3 over 4, we times both of those by 3, became 12, or 9 over 12, and this one we times by 4, so the 2 became 8, and the 3 became 12. These two are equivalent fractions for these. We just found equivalent fractions where our denominators were the same, so that we could subtract them like we've been doing. All right, and we get 9 minus 8 is 1, and we're looking at twelfths. I'm going to jump across to the whiteboard so that you can have a look at what I'm talking about. There we go. All right, so just to quickly recap something about common fractions and subtraction and why we don't change the denominator. Let's say, for example, we had 3/4, which I've colored in over there, and we're going to subtract 1/4. I think you can see fairly easily that those two can cancel each other out, doesn't matter which, and we're left with 2/4. All right, so 2/4 then would be 2 over 4. Now the reason why we don't change the denominator is because we're not changing the size of the piece. So if we made it, hang on, let me put my ruler on. If we made our answer 2 over 8, oopsie, ruler's now on and it shouldn't be. If we'd made our answer 2 over 8 by, oh, sorry, that's not even the right way around. Be 4 minus 4 is 0. We wouldn't even have, so it wouldn't even fit in here at all. In fact, this is an entirely illegal maths maneuver because we can't share out with 0 at the bottom. This will give you an error on your calculator if you try to do 2 divided by 0. So we leave the denominator as 4 because we are looking at quarters. Right, let's look at a couple more simple examples. I've got one of each kind. One where we've got a denominator where denominators that are different, we just have to change one, and one where we can change both. All right, so looking at the middle one first, I'm going to look. I see that I can do something to my 4 to make it into a 12. So what I can do is I can times 4, 8, 12. I can times that by 3, but what you do to the bottom, you do to the top. So my first number is going to stay unchanged at 5 over 12. My second number, 4 times 3 is 12, so my denominator is 12, and 1 times 3 is 3. So I've changed the denominators to be the same, and now that I've got denominators the same, I can do subtraction. So 5 minus 3 is 2, and 12 at the bottom. You might have a teacher who wants you to simplify your answers. If you do, you would do it as follows, but I'm not going to focus on that this lesson because that's a different skill. Not something I want to bring the attention to this lesson. But what I would do is I would say to myself, what can go into, or is there anything that can go into 12 and into 2? I notice that 2 goes into there, and 2 goes into there 6 times, and 2 goes into there once. And in fact, that is my simplified answer, 1 over 6. Right, let's have a look at the last of our examples from this section, where we've got 2 different denominators, 5 and 6, and we unfortunately can't find something to make a 5 into a 6 or to make a 6 into a 5. So we're looking for something that both 5 and 6 fit into. If your maths is good and your times tables are good, you would pick it up immediately. But if not, then here's a good way to get there. I'm going to jot down the first few terms of each of the times tables. I normally do 5 to start with. And let me do 6, 12, 18, 24, 30. Okay, I haven't found anything, so I'm going to do some more. There we go. Got one. 30 is in both of those times tables. All right, so I can now change each of these fractions into a fraction with a denominator of 30. So to change 5 into 30, I'm going to go 1, 2, 3, 4, 5, 6 times 6. And what you do to the bottom, you do to the top times 6, which means 3 times 6 is 18, and my denominator will be 30. So that's an equivalent fraction there. Leave my minus in place. What am I going to do to my 6 to turn it into 30? 1, 2, 3, 4, 5. Well, we're going to times it by 5. And what you do to the bottom, you do to the top as well. 1 times 5 is 5. 6 times 5 is 30. Right, I now have a common denominator, which means that I'm allowed to subtract. 18 minus 5 is 13. And we're looking at 30ths. If this could simplify, I would simplify it, but it can't. And one of the clues that you have to that is, if you're a maths buff, if you've got a prime number, you won't be able to simplify it unless it also goes into the denominator. All right. So that's what we're looking at when we are subtracting common fractions. I want to go back to the slideshow and have a look at when we are subtracting mixed numbers. Right. Oh, I didn't put in my time lapse, but let's have a look through it. Okay, so when denominators are the same, we've got 3 and 2/3 minus 2 and 1/3. So we have the denominators the same already, so we don't need to worry about it. So we're going to look at the whole numbers. 3 minus 2 is 1. And now we look at the fraction part. 2/3 minus 1/3 is 1/3. That's how we get our answers. When we've got different denominators, before we do anything else, we have to make our denominators the same. So I noticed that 3 and 4 both go into 12. It was one of our examples earlier. All right, so I noticed that. So I'm going to make this one into 12. So I times that by 4 times that by 4, which gives me 8 over 12. So this is an equivalent fraction for this. And this one I'm going to times by 3, which gives me 3 over 12. And this is an equivalent of this. Now that I have the same denominators, I can subtract. 10 minus 2 is 8. 8 minus 3 is 5. Denominator stays the same. Right, let's go back and practice that on the whiteboard. So, subtracting mixed numbers. I have some examples here. Let me scroll down there. Okay, looking at the first one first. That makes sense. Why do I say silly things like that? All right, I already have denominators are the same, so I don't need to change them. So I'm going to subtract my whole numbers first. 2 minus 1 is 2. My denominator is going to stay the same. 3 minus 1 is 2 as well. 2 and 2/4, which can simplify, but not this lesson. We're not going to do it. Right, looking at the next one, again, where we have the same denominators. I put this one in because sometimes you'll come across this situation and you might get a little confused because it might be a little bit unfamiliar. It's the same, so I don't need to worry about changing the denominators. So I'm going to go 2 minus 1 is 1. And then I'm going to go 1 minus 1 is 0. 0 over 2. So in other words, my answer is 1 and no halves, which is just the same as saying 1. So it's very possible to end up with a whole number as your answer and no fraction. You might also encounter one of these like in my next example. 5 and 7 over 12 minus 3 over 12. So the difference about this one is you've got no mixed number as your second fraction. That's not a problem. It treats it just the same. If you want to think of it like this, there's a ghost 0 over there. Ghost 0. We just don't write a 0 when it's in the front because it wouldn't really make a lot of sense. Okay. So let's see where we're going with this. We've got denominators the same, so 5 minus nothing is still 5. 7 minus 3 is 4. Denominator stays the same. Okay. Next type. This type where we only have to change one of our denominators. So having a look over here, I have different denominators. The first thing I must do is make my denominators the same. So I notice I can turn the 3 into a 6 by doubling. Times 2, what you do to the bottom, you do to the top. First fraction stays as 6 and 5/6. Second fraction becomes 3, whole number doesn't change, and 2 over 6. Now that I have denominators that are same, I can actually do my subtraction. So 6 minus 3 is 3. 5 minus 2 is also 3. There's my answer. Another one of those. It doesn't always have to be the second fraction that changed. This happens that in these examples that I've got, it does. So I notice that if I want to get 5 to 10, I can double it. So my first fraction is going to be still 10 and 9/10. It's not changed, it's just rewritten. And then I'm going to subtract 6, stays the same. 2 times 4 is 8 over 10. Now that I've got the same denominators, I can do my subtraction. 10 minus 6 is 4. 9 minus 8 is 1. And we're looking at tenths. And there's our answer. Okay, let's look at where we have to change both of the denominators. Okay, 6 and 4, we need to find something that both of them go into. Now, up until now, some of you might have been getting a little clever and noticed something like, where is it? It was on my slides. You might have noticed that very often we times it by the other number when we're multiplying to get the same one, but it's not always the case, and 6 and 4 is an example of that. So I'm just going to, on the side, notice. So I do see that if I did 6 times 4, I'd get 24. And 24 is a number that they both go into. But it's not the smallest number that they both go into. So I'm going to jot down the times table for 6, 12, 18, 24, and 4, 4, 8, 12. And that's when we notice that actually the lowest common denominator, the smallest common multiple, is 12. And that's what we're going to change our denominators to. Right. Okay, so I want to change 6 to 12, which I do by timesing by 2. What you do to the bottom, you do to the top. And the other one, okay, so let's actually just write that one in now. So the 8 stays unchanged, and 2 times 5 is 10, and 2 times 6 is 12. Then we have a minus, and now we go, what do I do to a 4 to make it into 12? 4, 8, 12 times by 3, so minus 1, and 3 over 12. Now that we have our denominators the same, we can subtract. 8 minus 1 is 7. 10 minus 3 is 7. 12. Final answer. One more of those, and then we get to the real tricky stuff. Tricky stuff. It's not really tricky. I'll show you how. Okay. So we're looking for a common factor of 7 and 3, a number that both of them go into, because our first step has got to be to get the denominators the same. So you can start off by doing your times tables if you want to find it. If you're not sure, I always start with the biggest one. 7, 14, 21, 28. Let's see if that's enough. 3, 6, 9, 12, 15, 18, 21. There we go. 21 is our common denominator, the smallest one that they both go into. All right, so I want to make my denominators 21. To make a 3 21, I'm going to times it by 7, and yes, it's going to get stuck in your head. What you do to the bottom, you do to the top. What you do to the top, you do to the bottom. All right, so my first number is now, or my first mixed fraction is now 9 and 14 over 21. My second one, let's use yellow. No, yeah, that's fine. Times by 3, times by 3. So minus 4 and 3 over 21. And that gives us, let's just shift you over so you don't go behind my picture, equals 9 minus 4 is 5. And 14 minus 3 is 11. 21. Now, some of your teachers may stop there this year. That might be as hard as it gets, but I feel like that would be leaving the lesson half completed, and so I'm going to get on to one like what you can see in yellow at the bottom. And you'll see the problem with that in a moment. But before we do, I think just to get our strength up, we should have a Nomu hot chocolate break, just to relax our brains and get them ready for some more hard work. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. If, like me, you have a moustache, just make sure you don't get any hot chocolate in your moustache. What are you doing in grade 5 anyway, with a moustache? All right, just being silly. Okay, back to maths. Here we go. I'm going to start doing this exactly like the other ones we've done until we can see what the problem is. Okay, step 1, make my denominators the same. Well, that's easy. I'm just going to have to change the 2. So times 2 times 2. First fraction is going to be 5, and a quarter still, minus, and the second fraction becomes 1 and 2 over 4. All right, no problems so far. Let's do it. Yeah, we can still fit it in there. Okay, well, 5 minus 1 is 4. Denominator is 4. 1 minus 2. I've got 1 and I've got to take away 2. That's a problem. What am I going to do? Put a minus 1 up there? Right. Now this is where the problem comes. And we are going to need to borrow from our neighbor the whole number. And that is where things get a little bit trickier. All right, so I'm going to start off with these 3 in black, just to naturally guide you towards what makes sense. Okay, now many of you would just be able to do some of these by inspection. If we've got 8 minus 1.5, well, that's easy, it's 6.5. Okay, maybe you did it by inspection. But let's puzzle this out a little bit mathematically. Okay, I've got 8 over here, and I need to... Okay, well, if I take away 1, then I've got 7. But now I've still got to take away a half from my 7, which would lead me to 6.5, which is the answer I got. Okay, so I kind of have to borrow from my whole number. So, could I then say 7, and let me write a fraction next to it? What fraction should I use? I'm going to jump up a little bit on my screen over here to this very fun, very useful fact. Anything divided by itself is 1. So if I have 2 chocolates and I share them with 2 people, each person gets 1. If I have 5 chocolates and 5 people, each person gets 1. Mathematically, I'm saying 2 over 2. 2 divided by 2 is equal to 1. 5 over 5 is equal to 1. 18 over 18 is equal to 1. 1,000,000 over 1,000,000 is equal to 1. All right, that's a useful thing to know. So I'm borrowing from my 8. What kind of fraction should I take? I could take, why don't I take quarters? So let me say, okay, 7 and 4 quarters, because remember 4 over 4 is 1. Zoom in a little bit over there. Yeah, 4 over 4 is 1. Okay, fine. So then my second fraction was minus 1.5. Oh, but now my denominators are different. Now I'm going to have to change the one denominator. Why don't I be a little bit smart here and say, because I'm already working with halves, let's take that 1 as 2 over 2. So this is 1 and this is 8. This is 7, and together that's your 8 that we started with. So I haven't done anything other than move a little bit of my whole number over to being a fraction. And as soon as you see it in this form, it suddenly looks a whole lot easier, doesn't it? So I'm back to looking at a whole number minus a whole number. So 7 minus 1 is 6. 2 minus 1 is 1. And we're looking at a half. Oh my goodness, 6.5. That's what we were looking at. That's what we did by inspection. Let's do another one. I'm sorry to get excited about this, but I do find maths has a wonderful symmetry to it. It just kind of works, fits together nicely. It makes me feel good. I hope it makes you feel good too. All right, so let's look at this one. 7 minus 3 and 5/6. Well, I know that I'm going to have to borrow from my 7. So why don't I go ahead and say, well, I'm looking at sixths. Why do mathematicians have to make it so complicated to say? So I'm going to take my 7 and I'm going to keep 6 of them in the whole number. and then I'm going to make one of those 7 into the fraction. And because I'm already looking at 6's, I'm going to make that 1 6 over 6. All right, that way I'll be able to borrow minus, and the next part doesn't change. I've kept it the same, 3 and 5 over 6. Now I'm able to subtract. 6 minus 3 is 3. 6 minus 5 is 1. And my answer is 3 and 1/6. Okay, just because I like to throw in a little bit more complicated numbers, it works identically even when we have 17ths. All right, so I'm going to take my 10. I'm going to make it 9, and then I'm going to put some of it into a fraction form. And because I've got 17 at the denominator on the other side, just to make my life easier, I'm going to do 17 on this side as well. So 17 over 17 minus, and the other one stays as 14 over 17. 4 and 14 over 17. 9 minus 4 is 5. 17 minus 14 is 3. And 3 over 17, 5, and 3 over 17. There we go. Now there's a reason why I started with whole numbers, is because this process here can also be done with mixed numbers, but it takes a little bit more, it takes the understanding of what we were doing and why we took it as 17 or 6 or 2 to make sense of what I'm going to do now. So I'm going to slowly but surely explain it, and then I'm going to show you a shortcut that will help you as long as you understand what you're doing, so that you don't have to go through the process each time. Okay, let's have a look at what we've got here. I've given these two as having the same denominator. All right, so let's start off with doing this. So I've got 5 1/4 minus 1 3/4. Okay. I can see already that this is not going to work because I can't take 3 away from 1. I can't take 3 when I only have 1. All right, so what are we going to do here? Well, like we did before, we're going to borrow from the whole number. I'm going to write something and it's going to look a little bit messy, but try and stay with me. All right, so I know my whole number is now going to come 4 because I'm going to be putting some of that into fraction form. I'm looking at quarters, so I'm going to be smart and give my 1 as quarters. So this is my 5. I've just written it slightly differently. Now, I already had a quarter there. This is the thing that looks messy, and we would never ever write that. But it's for the understanding that I'm writing it. We already know that 5 plus 1 is 4 plus 1 is 5. I always do that. I say the answer when I meant to say the question number. All right, so instead of saying this thing here, we are going to write it as 4 and 5 over 4. All right, so we took some of the whole number and we added it to the numerator. Now, if you've already looked at the lesson where we did adding mixed numbers, we came to this situation and I told you it's not actually a legal maneuver to write a mixed number when you've got an improper fraction. But we're just doing it so that we can do the understanding part and the subtraction part, because our answer is not going to end up like that. Okay, so I'm sort of going to skip down onto this level here. So I was doing that, and then I was minusing 2 3/4, which is this number here. All right, and now that I've got this is now something I am able to do. So 4 minus 2 is 2, 5 minus 3 is 2, 4 stays the same, and there's my final answer. All right, let's do another one of those with the scribbles, and then we'll see if we can do it without the scribbles. Okay. So having a look at 7 1/6 minus 3 5/6. So already I can see that I can't take 5 away when I've only got 1. So what I'm going to do is I'm going to borrow from my whole number. So my whole number will become 6. I'm looking at 6, so I'm going to borrow my 1 is 6. That's my 7. I already had a 1 over 6 over here, and so I've got it there. I'm going to put those together, and I'll have 6 and 7 over 6. And I'm going to be subtracting this number here, which is 3 and 5 over 6. Right. At this point, we can carry on per normal. 6 minus 3 is 3. 7 minus 5 is 2 over 6. And there's our final answer. Oh, we've moved over behind me. There's our final answer. All right. Okay, so let me look at that trick that I was showing you. The trick that I said, once you've understood, you'll be allowed to do this. Okay. I'm going to actually take these out and put them on the side here. All right, so I'm going to say we had 5 1/4, and we made that 4 and 5 over 4. That's what it was. We had 5 1/4, and we made it 4 and 5 over 4. And down here, we had 7 1/6, and we made that into 6 and 7 over 6. Right, now we can focus just on the writing that I've got over here. Okay, so how are we going to get there in an easy way? All right, well, what I notice is that each time this is going to go down by 1. So my whole number is going to go down by 1 because I'm borrowing from my whole number. My denominator doesn't change. It stays the same in each of those cases. What changes is the numerator. Now what I notice is that this numerator became 5, which is the same as saying those two added together. This numerator becomes 7, which is the same as saying that one added together. So if we move over just a little bit more to this side, trying not to overlap. If we had, let's pick 5 and 2 over 7, or 3 and 8 over 17, doesn't matter what they are. How are we going to go about making those into what we need? Well, we know I'm going to do them one after the other. This one is going to become 4. Denominator is not going to change. And to get the numerator, I add those two together. 7 plus 2. Oh, move down. Let me start that explanation again so that you can see where I'm working. All right, I've just written down 2 random examples. Now, I know that this number is going to go down by 1. It'll become 4. I know that my denominator will stay the same. My new numerator is going to be those two added together. All right, let's do that again, and then we'll start practicing it within some problems. I know this number is going to go down by 1. I know my denominator is staying the same. My new numerator is going to be these two added together. So 17 plus 8 is 25. Right, let's practice that within the realms of some problems. All right, now these two I've moved. Let's clear things up so you can only see them. These two I've done so that we have mixed numbers and we've got different denominators. So we're going to need to make them the same before we can subtract. Step 1, make the denominators the same. I see that both of these go into 15. So I'm going to times by 5, times by 5, times by 3, times by 3. This now becomes 6 and 10 over 15 minus 3 and 12 over 15. And you should be able to see that we can't take 12 away from 10. So now we're going to have to borrow. Now here comes the practice of what we were just talking about. My whole number is going to go down by 1. I'm going to write this underneath so we can just keep things in place. Oops, not by 2, by 1. Right. My denominator stays the same. My new numerator is those two added together. This number doesn't change. Now we are ready to do the actual workings. 5 minus 3 is 2. 25 minus 12 is 13. And denominator stays the same. And there is our answer. Another practice round. If you're feeling confident, give this one a go now. If you can get this where you have to borrow now, it's going to make things easier in both grade 6 and grade 7. Right. Okay. Our denominators are different. We need to make them the same. In this example, I notice I can do something to just one of them. All right, so I'm going to make them both the same. So the first one now becomes 8 and 4 over 14. And the second one remains unchanged as 3 and 9 over 14. I've noticed I cannot take 9 away from 4, so I'm going to have to borrow from my 8. The 8 decreases by 1. Denominator stays the same. Add those two together to get my new numerator. Right, all good. We can do the subtraction now. 7 minus 3 is 4. 18 minus 9 is 9. Denominator stays the same. Okay. It's going to just take a bit of practice with these, but I'd like to practice them within some word problems. So today I chose people from a restaurant near where I live, 2 waiters and one of the owners as my names for these word problems. I've mentioned before that we just come up with themes for names as teachers. We never really know where to look for different names. And you've always got to be careful not to make a naughty sum about one of your students in case they get upset, offended. All right. It's a word problem, so we have to have a number sentence first. Tracy makes 5 3/4 liters of juice or punch, whatever it is. So 5 3/4 liters. At her party, the guests at her party drink 3 4/5 liters. So that's going to be minus 3 4/5. All right, there's our word problem. Sorry, our number sentence. Now we do our workings. Okay, well, I have different denominators, so step 1 is going to be to make my denominators the same. I can see that 4 and 5 both go into 20. Remember our trick with the times tables, if you need to find it and you don't see it immediately. If I times that by 5, I'll get to 20. I must do the same to the top, so that becomes 5 and 15 over 20. The next one, times by 4 becomes 3 and 16 over 20. And if you're paying attention, you can't take 16 away from 15. And so we're going to need to change. We need to borrow from the 5. So it's going to become a 4. Denominator is going to stay the same. 20 plus 15 is 35 minus 3 and 16 over 20 unchanged. We can do this now. 4 minus 3 is 1. Denominator stays the same. Ooh, this is a tricky one. How are we going to do it? Well, you can jot down on the side if you're worried. I would suggest think of it like this. To get from 16 to 20 is 4. Then you can do a jump to 30, which is going to give you 14. And then you can do another jump of 5, so you end up with 19 over 20. Right, otherwise, if your mental maths is good, you can just work it out. All right, second last one. Juma, he served us the other night. Very nice guy. He was a trainee, but he was very good, and I definitely think we'll see him again. All right, so I make up the story about the pizzas in this, but I don't know what they get given. At the end of his shift as a waiter, Juma is given 4.5 pizzas for him and his fellow waiters to eat. So we've got 4.5 pizzas. Oh, I did it again. I didn't write down my answer in words to my previous question. I'm going to have to minus marks from myself. Okay, I'm going to quickly write down the answer to the previous question. Was it Tracy? Tracy had 1 19/20 liters of punch left. Okay, back to Juma and his pizzas. 4.5 pizzas. 4.5 pizzas for him and his friends to eat. That's far more than they can eat in a sitting, but he'll get to take the leftovers home. So together they eat 2 5/8. How much does he have left? Okay, so I notice step 1 is we have to make our denominators the same because they're different. But I do notice that we can turn this one into an 8 by multiplying by 4. And what you do to the bottom, you do to the top. So first fraction becomes 4 and 4/8. And the second fraction is 2 and 5/8. I can't take 5 away from 4. I have to borrow from my whole number. This number decreases by 1. Denominator stays the same. Numerator, I add them together. That one stays the same. And I get to my answer. 3 minus 2 is 1. Oopsie. 12 minus 5 is 7. Denominator stays the same. And not forgetting this time that a word problem. Juma takes almost 2 pizzas. 1 7/8. Wait. Pizzas. Oh, lucky guy. That's going to make a nice breakfast. Okay. Mike is another waiter from the restaurant. He's been there long, though. He's not a trainee anymore. Okay, Mike is running a trail run of 12 3/4 kilometers. 12 3/4. His watch tells him that he's already done 8 5/6 kilometers. How far does he still have to go? Well, we have different denominators here. We need to make them the same. So I'm going to start off by looking for something they both go into. I noticed they both go into 12. This was an example from earlier. But you can write down times tables if you're not sure. I always recommend write it down if you're not sure. Times by 3, times by 3. First fraction becomes 12 and 9/12. Second fraction, you're going to times by 2, times by 2. Becomes 8 and 10/12. Pirate, that's enough. I think he's just telling the person who parked outside our house that this is our house. All right. We can't take 10 away from 9, so we're going to have to borrow. That decreases by 1. Denominator stays the same. The new numerator we get by adding those two together. Second fraction remains unchanged. We can now do it. 11 minus 8 is 3. 21 minus 10 is 11. Denominator stays the same. All right. I hope that has helped you with how we subtract. If you're comfortable with borrowing from the whole number, then you're well ahead of what's required in this grade. I think it's really important that you do get ahead. But at the very least, you should be able to subtract your mixed numbers, where you subtract both numbers, and then you subtract the whole numbers and then subtract the fraction. And that's whether or not you are starting with the same denominators or different denominators, should be comfortable for you. Nothing really sticks in our brain unless we practice it, and that's what you need to do. So please click on the link below the video in the description to download a free worksheet from Worksheet Cloud so you can practice what it is that we've been looking at this lesson. Don't forget, if you haven't already, to get your parents to sign you up for Worksheet Cloud so that you have access to all of their worksheets and videos and stuff from all subjects, and that you also have access to that rewards hub where you can win those cool rewards like merchandise and from Worksheet Cloud and hot chocolate from Nomu to sweeten the breaks and possibly even that PlayStation 5. I just wish I was eligible for it, but unfortunately I'm not. Have a great day, grade 5s. I look forward to seeing you again soon.